Okay, section 3.2. Last time we worked with equations involving addition and subtraction. Today we're going to be talking about equations that we solve by using either multiplication and division. So most of these are going to end up being one-step equations. Again, very similar to the last assignment. And a lot of our purpose here is to just demonstrate what your work will need to look like for this class. Okay? In order to solve equations, isolate the variable by undoing the operation being performed on it. Remember, we talked about inverse operations. If the original equation's variable is multiplied by a number, isolate the variable by dividing. So here's an example of this type of problem. We have negative 3x equals 2. And let's make sure that we understand the relationship between that negative 3 and the x. So how are they glued together, right? What's the relationship? Are they being added? Are they being subtracted? Well, no, because we would see those signs. But when the negative 3 is pushed up right next to that x and they're kind of bumping up on each other, we know that that's a telltale sign of multiplication. Also, we talked about coefficients and variables. The variable is the x. We say that negative 3 is the coefficient of x. And remember that coefficients are multipliers. So the negative 3 is definitely multiplying the x. So how do we undo that multiplication? Well, we're going to divide by negative 3. And whatever we do to one side, remember, we have to do to the other side. So if we divide by negative 3 on the left, we're certainly going to divide by negative 3 on the right. Now there's a cancellation that happens out on the left-hand side. Negative 3 divided by negative 3, those cancel out, but they don't make a 0. With adding and subtracting, you cancel by creating a 0. With multiplying and dividing, you cancel out by creating a 1. So negative 3 over negative 3 is technically a 1. It's a 1x. And you're not going to notice most people write it that way, and you don't necessarily need to write the 1. We know that 1x is the same as x, so you can get away with just writing the x. But I want you to know it's there. It's important for you to understand how that works. So we're left with x equals, and 2 divided by negative 3 is just another way of saying negative 2/3. Pretty easy stuff. You could go back and plug that negative 2/3 in for x, and if you check it out, it should work. Negative 2/3 times negative 3, you're going to end up getting a negative times a negative is a positive, and 6 over 3 is 2. So positive 2, which is exactly what that number is. So this checks out. Okay, you notice that I did the work myself because I don't like how those equal signs you're seeing right there aren't lined up. So I'll be handwriting a lot of this work. Okay, if the original equation's variable is divided by a number, isolate the variable by multiplying. So sometimes the relationship is one of division. So this is x divided by 9 equals negative 25. I'll actually show you their work first. How are we going to get rid of that divided by 9? Well, we're going to do the opposite. Instead of divided by 9, we're going to multiply by 9. And whatever we do to one side, we do to both sides. So we're going to multiply by 9 on the left, and we're going to multiply by 9 on the right. Okay? The 9 on top and the 9 on bottom will cancel out because a 9 over 9 makes a 1. And then we just need to know what 9 times negative 25 is. It looks like that's going to be negative 225. You could plug that back in and make sure that it works out, and it definitely will. Notice how the equal signs are not lined up. That's no good. I am going to go through this one time just because I want to talk a little bit about the fractional aspect of this. So let me recopy. We have x divided by 9 equals negative 25. Okay. Notice that it's joined by division. We said joined by divided by 9. So I'm going to multiply by both sides by 9. My question to you is, why is it when we do this that most teachers are going to put the 9 up here? Why don't they put it in the bottom, let's say? Well, remember, we're dealing with fractions. And if that's an x divided by 9, x is in the numerator, 9's in the denominator. That 9 is really 1/9. 1/9, okay? And to get rid of 1/9, technically, we're multiplying by 9 over 1. So that's why we put the 9 kind of floating up in the air. It's really like 9 over 1. Kind of like how this guy over here, the negative 25, is technically negative 25 over 1. Okay? And that's why when we put the times 9 over here, we want it to be on the same level as that 25. Both of those numbers are in the numerator. Now you might not write the over 1 part of this, and I'm okay with that. Okay, no big deal. But I want you to understand that those numbers are indeed in the numerator. Okay, let's go through cancellations. So a 9 on top and a 9 on bottom make a 1. 9 divided by 9 is 1. And so we end up with 1x again. And remember, you don't have to write the 1, but you should know that it's there. And then on the right-hand side, negative 25 times 9, yes, that's going to produce negative 225. So what I have left right here, that is how I would want your work to look. You can plug in that negative 225 divided by 9. It will spit out a negative 25, so that answer does work. Okay, that's division. It's not the only type of fractional thing that we're going to have to deal with. Sometimes we'll have fractional coefficients. If the original equation's variable is multiplied by a fraction, okay, that's a fractional coefficient, isolate the variable by multiplying by the reciprocal. Let's take a look at what they're talking about here. And this one I'm going to do in my own handwriting. It says 14 equals negative 7/8 m. Okay. Now you should probably be copying these down with me and practicing them on your own. That way you are ready when it comes time for your official blue examples. 14 equals negative 7/8 times m, and I purposely gave myself some space there. All right, what do we do? How do we get that m by itself? Right now it's glued to the negative 7/8 by multiplication. Okay. When you have a fractional coefficient, the quickest way to undo it is to actually multiply it by its reciprocal. And we talked about reciprocals. What is the reciprocal of negative 7/8? Well, we're going to flip that, and we're going to get negative 8 over 7. That would be the reciprocal of negative 7/8. And whatever we multiply to one side, we're going to have to multiply to both sides. So that 14 is technically on top. It's like a 14 over 1. Make sure you put the 8 on top and the 7 on the bottom. We're going to multiply this side by negative 8/7 as well. Okay, why do we do this? Well, take a look at the huge cancel fest that's going to happen over here on the right-hand side. An 8 on top and an 8 on bottom cancel out. A 7 on bottom and a 7 on top cancel out. A negative times a negative makes a positive. Those cancel out. So I'm left with just plain old m over here. And that's why multiplying by the reciprocal is really powerful. It cancels out everything. Now I do need to clean this up over here and figure out what number I have. I've got some cross cancellation I can do. I've got a 7 on bottom, 14 across in the corner. I can divide both of these by 7. So 7 divided by 7 is 1. 14 divided by 7 is 2. So I'm looking at negative 8 times 2 is negative 16. And 1 times 1 is 1. And we know that negative 16 over 1 is just another way of saying negative 16. So negative 16 equals m. And you'd want to plug that in back over here to make sure that it makes sense, and it will work out. And you can see that when they do their work, you'll see the exact same thing. I just wanted to show you my rationale as we were going through it and keep the equal signs lined up. It looks nicer that way. Notice that the computer screen is going to have parentheses around these numbers. You don't have to show multiplication by parentheses. Using the little dot is fine with me. Okay, so we have undoing by division, undoing by multiplication, and then undoing by multiplying by a reciprocal. Okay, have that pencil and paper ready, because now you're on your own, and you're going to have to determine what type of problem you're looking at. Am I going to get the x by itself by dividing? Am I going to get the x by itself by multiplying? Is there a fraction involved? Am I going to have to multiply by some type of reciprocal? Those are the questions you'll need to ask yourself. Go ahead and do these on your own. Show all steps. Circle your final answer statement, and make sure you plug back in to check your answer. You should know that you're right before we go over answers. Okay, so you want to go ahead and pause now, and we'll reconvene to go over answers in a little bit. Go ahead and hit pause now. Okay, how did you do? Hopefully you're feeling pretty good about this. One thing I do want to mention ahead of time right now before we get into this is, you're going to have a lot of examples for this particular lesson right here. We're going to have 6 on this side, and I believe another 6 in example 2. Why? Well, your quiz for this chapter, the very first quiz you take, it's really tough. And you might think that what we're doing right now is very easy, but when I quiz you, I'm going to throw you difficult numbers and numbers that don't necessarily make sense inside your head. And you're going to have to rely on the process and not how the numbers feel to you. So if you know the process, great, you'll be fine. But if you're kind of skirting around the process and you're not really buying into all of this, you might find that your grade suffers on the quiz. So make sure that you're following the same steps that we're working on. All right, number 1, negative 5x equals negative 120. We're going to divide both sides by negative 5. Cancel those out. And we get x equals 24. Negative divided by a negative is a positive. 120 divided by 5 is 24. If you go and plug that 24 in, it will work. All right, let's take a look at number 2. 12x equals negative 156. We're going to divide both sides by 12. 12 divided by 12 is 1x, or just x. And then notice a negative divided by a positive is going to give us a negative number. And 156 divided by 12 is going to give us 13. Take that negative 13, plug it back in. It will work out. And I should have put the check mark over here on the 24. All right, negative 3x equals 17. Same thing. I'm ungluing by dividing by negative 3. Don't divide by 3. Divide by negative 3. That way you get rid of your negative sign at the same time. Negative 3 divided by negative 3 is a positive 1x, or just x. And then 17 divided by negative 3, that's already simplified. You can write that as negative 17 thirds. And that's totally fine. Or you could leave that negative sign on the bottom, or you could write that negative sign up top. Either way, those are all 3 different ways of writing negative 17 thirds. Don't feel like you have to turn this into a mixed number. It doesn't need to be negative 5 2/3, although if you have that, I'm sure it's fine. But the improper fraction is cool with me. If you plug that in, multiply it by negative 3, things are going to cancel out, and you're going to end up with a positive 17. It definitely checks out. All right, then we shift gears a little bit here on number 4. This says x divided by 6 equals negative 12. So how do we get rid of a divided by 6? Well, we're going to multiply by 6 on both sides. Or you could also have written this as multiplying by 6 over 1 on both sides. Okay? Either way, usually in my work, I know that I'm dealing with it over 1. I'll usually just write it like this, and that's fine. Okay? 6 over 6 cancels out, and you get left with x over 1, which is just x. Now I need to multiply that 6 times the negative 12, and that's going to give me a negative 72. So x should equal negative 72. If I plug that in, 4x, negative 72 divided by 6 will give me negative 12. So that works out. All right, number 5. How do I get rid of divided by negative 5? Well, I'm going to multiply both sides by negative 5. Not by 5, by negative 5. That way we can cancel the negative 5s in one fell swoop. All right, negative 5 on top, negative 5 on bottom. Cross cancels. It makes a 1. X over 1 is just x. 13 times negative 5 is negative 65. Plug in that negative 65, divide it by negative 5. It does spit out a positive 13. We are good to go. Okay. Number 6, couple different ways to do number 6. Now I'm going to do this the long way to begin with, because it's probably the way I would have done it when I was your age. How do we get rid of that divided by 2? Well, we can multiply by 2 on both sides. 2 over 2 is going to cancel out, but you are left with negative x over 1. Okay, that negative sign comes along for the ride. And you get negative x equals negative 150. Okay, do you remember how to get rid of that negative x? Hopefully you do. Divide by negative 1 on both sides. And that's going to leave you with x equals positive 150. And positive 150 is the correct answer. All right, now, there is a quicker way to do this if we go ahead and go all the way back up to the beginning. Some of you might have seen down the road that if you multiplied by 2, it was going to leave you with a negative x. And if you want to avoid being left with a negative x, another way of doing this is to multiply by negative 2. I know it's not the same number as the 2, but it will cancel out the negatives involved with your x. So here's what I'm talking about. The 2's cancel, and then the negative times the negative makes a positive. Those negatives cancel, and you're left with plain old x. Over here, since you're multiplying by negative 2, you go straight to the final answer. Negative 75 times negative 2 is positive 150. So I just showed you two different ways to do that problem. Either way is totally fine. Okay, how'd you do? Hopefully you got at least 4 or 5 of these right, maybe even all 6. That shows you're in a good spot. But we haven't really dealt with those fractional coefficients yet, and that's what tends to trip people up sometimes. So let's take a look at some of those. If you need to go back to the notes before you do this, that's fine. It is a blue example, so you do need pencil and paper. Go ahead and do all of these on your own first, show all the steps. Go ahead and hit pause now, and then we'll reconvene to go over answers. Okay, let's take a look at how we did. We'll start with number 7, 2/3 x equals 50. How do we get rid of that 2/3? Well, we're going to multiply by the reciprocal. So we're going to multiply both sides by 3/2. Notice I keep that 3 up top with the 50, and that 2 is on bottom, just like that 50 is on top, and there's really an invisible 1 right there. Okay? All right, let's see what cancels out. 3 on top, 3 on bottom, make a 1. 2 on top, 2 on bottom, make a 1. And I'm just left with plain old x. And then I have to do the multiplication here. I can cross cancel if you want. So some of you guys are going to say 50 times 3 is 150. 150 divided by 2 is 75. That's fine. Or you can go ahead and do the simplification now. 2 divided by 2 is 1. 50 divided by 2 is 25. Just cross canceling. 25 times 3 is 75. So you should get x is 75 over 1. And that simplifies to x equals 75. All right, take that 75, plug it back in. 2/3 of 75 is 50, so that totally makes sense. All right, on number 8, we got negative 1/4 x equals 12. How do we get rid of that negative 1/4? Well, we're going to multiply it by its reciprocal. And the reciprocal of negative 1/4 is going to be negative 4 over 1. Okay, and I'm multiplying both sides by negative 4 over 1. 4's cancel, 1's cancel. Negative times a negative is a positive. This leaves me with just plain old x. Okay, now 12 times negative 4 is negative 48 over 1, which is just going to be negative 48. So x equals negative 48. Go back and plug that in. A negative times a negative is a positive, and 1/4 of 48 is 12, so positive 12 totally makes sense. All right, over here on number 9, to get rid of that 3/8, we're going to multiply by 8/3 on both sides. And I just put this 1 in here just to kind of match up my fractions. 8's cancel, 3 cancels. You're left with x. And then I might do some cross-canceling here. The 3 and 36 look pretty ripe. Divide by 3, I get 1. Negative 36 divided by 3 is negative 12. So I just need to know what negative 12 times 8 is, and that is negative 96. Okay, if you go back and plug that in, it might not be as easily mentally to do, but you can multiply it out, and when you plug in that negative 96, multiplied by 3/8, it will spit out a negative 36. All right, let's take a look at the next one, number 10. I've got 13x equals negative 741. Okay, I'm going to divide both sides by 13. So this one is not a fractional coefficient. It's a whole number coefficient, so I'm going to just divide both sides by 13. I get plain old x over here. And then negative 741 divided by 13, that's probably not mental math. You might need to use a calculator, or you can do it out the long way. I do know that a negative divided by a positive is going to be a negative, and my sources tell me that this is negative 57. So I hope that's right, and if not, you better bring it up to me in class tomorrow. It feels right to me. All right, number 11, x over 4 equals negative 3 over 7. Okay. Well, there are many ways to do this. I mean, this is also a proportion, but we've been working with equations, so how do we get rid of that divided by 4? Well, we can multiply both sides by 4, or 4 over 1, because really that's a 1x over 4. It's like a 1/4 x. So you can use reciprocals here if you want. Multiply this other side by 4. And I like the 4 over 1 here because I do have a fraction, so I like having a numerator and a numerator match up with a denominator and a denominator. Okay, on the left, 4's cancel, and you're left with x over 1, which is just x. On the right, negative 3 times 4 on top is negative 12. And 7 times 1 on the bottom is just positive 7. And that is already reduced. So my answer here is negative 12/7. All right, moving on to the last one, and hopefully you're doing well on these. I've got negative 3/4 x. How do I get rid of that negative 3/4? Well, I'm going to multiply it by its reciprocal, which is negative 4/3. I have to multiply this guy over here also by negative 4/3. 4's cancel, 3's cancel, negative times a negative is a positive, just left with plain old positive x. 5/8 times negative 4/3. Now that's what we have to work on now. You can do some cross canceling here. I'm actually not going to cross cancel this one. I'll just do top times top. 5 times negative 4 is negative 20. 8 times 3 is 24. So I'm left with a fraction, negative 20 over 24. That can be reduced. I can divide both the top and the bottom by 4. And when I do that, I should get negative 5 over 6. And so hopefully your answers match up with mine. And I would say if they do, you're in a pretty good spot. Okay, that's it for tonight. Please use this as something to go back over, especially on the ones that maybe you weren't comfortable with, the ones that maybe you didn't get right the first time, because when it comes quiz time or comes test time, I promise you, if you haven't done your homework well, it's definitely going to be apparent to me. All right, good job on this, and good luck on the assignment.